Which one you want to
this? Apart from these two, which one you?
Sir, you can start the session.
Yes, good evening, students. So in last two classes, what we discussed with respect to the thing is material properties as well as stress and strain relationships, and also we discussed regarding thermal stresses especially. So in this particular class, let us be move on to in detail of thermal stresses. In thermal stresses especially, you are having compound bars. Compound bars means if more than two different materials are subjected to thermal stresses, what are the changes expected in the material, and few of the numerical associated with MCQ questions we are dealing in this particular class. And also in last class, we just touched regarding elastic constants and relationships. So in this particular class, we will discuss regarding elastic constants also. If time permits, we will move on to two-dimensional stress system. That is your principal stresses and principal strain. It's a very, very important topic. So for the understanding of that particular topic, we must know one-dimensional stress and strain analysis. Whatever we discussed in last two classes, that is all related to one-dimensional stress analysis. That is whatever we discussed regarding tapered single bar subjected to so and so forces, what is the stresses induced in that bar, all those things are related to one-dimensional thing. So let me start. Okay. So while we are doing thermal stresses majorly, the thing is, so what are the equations in thermal stresses, especially last class we discussed it. If a bar is subjected to thermal stresses,
delta T into L.
Yes, the first thing is what is the change in length, DL or delta L? Alpha T
Delta T into L.
delta L, alpha TL or delta TL, alpha delta TL, not delta L, alpha delta TL, where delta T equals, that is
temperature
T1 minus T2 temperature degree in centigrade, right? And also what we discussed, the strain. What is the strain? What is the strain? E?
Alpha into delta T.
Alpha into T, delta T. And also we discussed regarding stress, that is thermal stress, So the thermal stress in this free end, what is the thermal stress in free end? Zero. What is the thermal stress if it is subjected to here also fixed and both the side is fixed? What is the thermal stress? Alpha into T into E, not L, E. So these are the very, very important thing. Now let us be move on to the thing is, if there are two materials, two different materials, that's a very, very simple case. Okay, you must know, because with the MCQ, you cannot predict the questions, right? You must know. Okay, if there are two materials, see this is material number one and another material is having different rigidity model, structural rigidity. This is EI, this is 2EI, something, it's different. So on that cases, what happens? This is alpha 1, this is subjected to temperature alpha 1, and this is subjected to alpha 2. Then what are the expected thing? What is DL expected? What is DL expected? That is alpha 1, T1, L1 plus alpha 2, T2, L2. Where DL is? DL1 plus DL2, DL1 plus DL2, which is equal to same thing, alpha 1 TL1 plus alpha 2 TL2. So next, what is DL? What is DL? General expression. What is DL? PL by, what is displacement? DL. PL by AE 1 plus PL by AE2. This is same. Alpha 1 TL1 plus alpha 2 TL2. So if the materials is like this, that is connected to one with other, so we can easily predict the whatever the temperature stresses, because what is the strain, what we are required, the thing we can calculate easily. But the thing is, if in some cases what happens, if the bar is subjected to like this, one above here there's a brass rod, here it's a steel rod, then there are different cases, there are different cases comes into picture. On that case, what you have to do, this deformation will remains as it is, but here there is a alpha 1 minus alpha 2 T into L. This is the very, very important thing you have to remember, because when there is a steel, it is exhibiting tension. Where there is some other brittle material like whatever bronze, copper, some other material, it's not having that much of elasticity. On that case, it's having compression. So one is positive, other one is negative, one under tension and one under compression. So on that case, you have to do like this. So we will go on to MCQ questions. You are getting the idea in detail what we have to do. So let we move on to MCQ part. Yes, the thing is, this is whatever we solved in last class, right? Any doubts in that particular problem? Yesterday we solved. Okay, here. This is not. You just see the 26th question. The coefficient of thermal expansion of mild steel is A equals K into 10 power minus 6 per degree, where K is about. See, it's a direct question. Here, what he is asking, he's asking what is the thermal expansion of mild steel? It's a standard value. Please, any guess? What is the answer? For steel, what is the thermal expansion? You must know that standard value. Any guesses? It's a 8 into 10 power minus 6 or 12 into 10 power minus 6 or 16 into 10 power minus 6. What is the answer for steel, mild steel? What is the thermal expansion? It's a standard one. 12. So B is the answer. It's a direct one. So generally they will ask the thing is, what is the regular? Generally they will ask mild steel. They may ask copper. Okay. So there are a few certain things. I will provide a material. You just go through that materials. You are getting the idea. It's a standard thing. They will ask directly. The answer is B. Next, we want to 27th question. See, if the temperature changes from T0 to T in a simple bar with both ends are constrained, which means fixed, and having modulus of elasticity E, thermal quotient of alpha, the thermal stresses due to the temperature rise is. Yes. What is the answer? This is once again the definition. What is the thermal stresses due to constraint? If it is a free end, there is no stresses, but it is constrained. What is the thermal stresses?
E alpha T minus T naught. Option
Yes,
C.
E alpha T minus T naught. That is option number C. Yes. If in some cases they have asked like delta T, in this case they have given T naught and T. Clear? So this is problematic numerical associated equation. Any doubts? Next, see the question. A steel bar of 5 mm is a 5 mm steel bar is heated at 15 degree to 40 degree and it is free to expand. The bar will induce what? It will induce. It will induce thermal stresses, or it will induce shear stresses, or it will induce tensile stresses, or compressive stresses, or no stresses.
No stress.
Yes. Why?
It is free end.
It is free end. That's the thing. So in previous case, we are having constraints. So on constraints, whatever we are getting the equation alpha TE, but it is a free end. In free end, we are not having any kind of stresses. In free end, we are not having any kind of stresses. Therefore, the answer is option E. Yes, this is a very important one. Just go through the problem. A steel rod having cross-sectional area. A steel rod having cross-sectional area. A. How much? A steel. A steel. Area of steel rod is having cross-sectional area 3 square centimeter. 3 square centimeter. Connected to a two parallel walls. It is connected to a two parallel walls. This wall is connected by a steel rod having 6 meter apart. The rod is having 6 meter apart. And when the rod is heated, it is heated to temperature of T equals 100 degree centigrade. The nuts at the ends of tightened up, the pull exerted by the bar on cooling. So initially it is in 100 degree centigrade. After cooling, what happens? It will get a contraction. So the next temperature is 20 degree. So what is the temperature now? The difference in 80 degree centigrade with the not yielding, and assume the value of alpha is given and the value of E is given. What he is expecting in kg? What he is expecting? What is the ultimate aim of the problem? What it indicates? Is given temperature. Force. Yes. Exactly. Is asking to compute the force. P value in kg. It's asking to compute the force. Then what is the equation for stress? For temperature stresses, general equation. What is the general equation?
Alpha
Thermal equals
into E.
what is the equation? Alpha
T
T
into E.
E. Yes, alpha TE. What is the alpha value? 0.00012 multiplied by what is the T value?
80.
80. Yes. What is the Young's modulus value?
2.1.
2.1 into 10 raised to the power of 5. 2 point here. What is sigma? What is sigma? What is stress? Stress is P by A. This is a general thing.
Yes, sir.
What he is asking, he is expecting to compute P value. But we must know what is stress. Stress is load per area. Now, what is P now? P equals area into, what is area? Area in 3 square centimeter. But all things are in, this is in Newton per millimeter square, right? In MPa. So if you convert this 3 square centimeter to 3 square millimeter, how much?
10 raised to -4.
Yes. So what you are getting, that is centimeter to millimeter you are getting. So 3 into 10 power 4, that is 10 square. So centimeter, 1 centimeter equals 10 mm. So square. So 10 square area, that multiplied by whatever this value. Please do this. Multiply by this value. How much you are getting this value? 0.00012 multiplied by 80 multiplied by 2.1 into 10 power 5. Yes. How much you are getting? Compute the P value. What is the P value?
So divided by 9.81 ಮಾಡಬೇಕಲ್ರಿ sir?
Yes, divided by 9.81. Why? Because you do with 10 or 9.81, no problem. You're getting approximately near answers. Because whatever you are getting P value in Newton, that value you have to get in kg. The ultimate aim is all in kg, right? So how much you are getting?
6048.
Yes, you are getting, I think 6048, right?
Yes.
6048 kg you are getting. So what is nearby value? 6057 is the answer. So any doubts? Yes, any doubts? Okay, clear. Yes, next. Yes, next we move on to the next topic. Whatever we in last class we discussed regarding elastic constants, right? Last class we discussed regarding elastic constants. See, what are elastic constants? What are elastic constants? Yavyadappa? What are important elastic constants? What are elastic constants? I am not asking the relationship. What are elastic constants? The first one is Young's modulus. Next is rigidity modulus. Next one is bulk modulus and Poisson's ratio. And also you have to, what is the relationship between E and G? What is the relationship between E and K? This is very, very important. First one, what is the relationship between E and G? Relationship between E and G. What is the relationship between E and G?
E is equal to 2G into 1 plus mu.
E equals 2G into 1 plus mu. What is the relationship between E and K? E equals 3K into 1 minus 2 mu. Yes, if you eliminate mu value, you are getting K and G, E in terms of K and G, right? That's the thing we will just see in MCQ part. But these are the two equations you must remember to solve a numerical as well as MCQ questions. Okay, we will discuss regarding few of the numerical one by one. Yes, here in terms of bulk modulus K and modulus of rigidity G, the Poisson's ratio is expressed as. Yes, any guesses? What is the answer? This is a very direct question. Yes, C. Others? What is the relationship?
C, option C.
Yes. See how we are arriving this particular thing. The thing is, we know that the first thing is E equals 2G into 1 plus mu and E equals 3K into 1 minus 2 mu. You have to express it. You have to require mu value. So to get mu value, what you have to do? You have to take what is mu here. Here, if you want mu, you have to multiply with this. So you are getting E equal 2G plus 2G mu. So if you want this, you just take this value in the right side. It will become 2G minus E equal 2G mu. If you want mu, it will become 2G minus E divided by 2G. You take this as equation number 1. Next, from this, you have to arrive one more equation. How to arrive one more equation? You just multiply. So you are getting like E equals 3K minus 3K mu. Here, if you want mu, then you just take E 3K minus E, which is equal to minus 3K mu. If you want mu equals, if you take minus outside, it will become E minus 3K divided by 3K. Now, this is equation 2. Now, if you equate these two equations, so what you are getting? Equate these two equations. So 2G minus E divided by 2G, which is equal to E minus 3K by 3K by 3K. So if you do cross multiplication, finally you are getting 6G, and here also you are getting 2G. So finally, if you do sum of the modification, you are getting 3K minus 2G divided by 6K plus 2G. So the option is C. So don't do all these circles. This is the thing is, you must remember, try to remember the things. Okay. If you remember, you can easily, whatever the answer, you directly tick the answer. 3K minus 2G divided by 6K plus 2G. Next. Yes, this is a very, very important thing. The bulk modulus of elasticity of material is twice of its modulus of rigidity. What is the Poisson's ratio of the material? See what he is given. ಏನ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ? The bulk modulus. What is bulk modulus? What is the symbol for bulk modulus?
K.
K. So what he is given, the bulk modulus of elasticity K of the material is twice of the G. So is given K equal
2G.
is given that K equals 2G. K equals 2G. What is mu? Yes. What is the relationship between K and 2G? K and G? Or you can take which equation you are going to prefer? Which equation?
And KZ divided by K.
Yes, that is you just take the equation, that is or you can directly just take the equation E equals 2G or 3K, right? 3K 1 minus 2 mu. So in this case what happens, instead of K he is given that, and you are having one more equation, E equal 2G into 1 plus mu, right? So here what he is given, K equal 2G. If you substitute here K equal 2G, you are getting E equals 3 into 2G into 1 minus 2 mu, right? So you are getting 6G into 1 minus 2 mu. If you equate to this equation E as well as to this equation, so E get cancels, here GG get cancels. So here in this remaining term is 2 plus 2 mu, which is equal to, here the remaining term is, what is the remaining term here? 6 minus 6 into 2, 12 mu. Now if you take whatever 2 mu on this side, you are getting 14 mu, which is equal to 6 minus 2 is how much? Minus 12. If you take minus 12 this time, or you just observe how much you are getting here, 6 minus 4, right? So what is mu? 4 by 14. What is 4 by 14?
2 by 7.
2 by 7. Yes, 2 by 7. Any doubts? The thing is, we have considered two equations and we compared the equations. Or you can do like, if you remember the equation, what is the equation you have to remember for this problem? Where you are eliminating the K and G, 9 kg divided by, okay? So that's an tedious one. That's why what I told, if you remember these two equations, E equal 2G, 1 plus mu, E equal 3K, 1 minus mu, these kinds of problem, it's a conditional oriented problem, can be easily determinable. Can be easily determinable. So any doubts? If you facing any doubts, please ask. I will clarify. Ena doubts idre alle kelrappa. Yava section artha aagta illa anta. These are very, very important, straightforward questions. Clear? Shall we move on to next question? So any doubts? Okay. So this question is over. Yes, this is also over. Yes, this is related to your Mohr circle, that is two-dimensional stress analysis. So let's see if any of question we missed in this sections. No. Okay. So let us move on to the next topic, that is two-dimensional stress analysis, or principal stresses and principal strains. So what is meant by two-dimensional stress system? Any idea? This is very, very important topic. Two questions, probably 1 or 2 questions, definitely I'm expecting your examination. This is principal stresses. They may ask like compute tangential stresses, or direct normal stresses, or they may ask to compute major principal stress or minor principal stress. There are several things. Okay, let it be. It is very easy topic, nothing to worry. Okay, let me tell me what is meant by two-dimensional stress. Yes, you have to interact. If you're having any doubts, I will clarify, but you must know, right? You must know little bit. So because these types of exams, we are going briefly. We are not having enough time to go in detail. So that's why please try to interact. If it is wrong, no problem. Try to interact. So any idea what is mean by two-dimensional stress? Any idea? Or biaxial stress? So uniaxial stress, it's a one-dimensional one. So now biaxial stress system or principal stresses, in other words, or we can say that this is a little kind of two-dimensional stress analysis. Yes. Any answers? What is meant by two-dimensional stress? Or
X and Y directions.
yes, compound stresses. Compound stresses are two-dimensional stresses. Compound stresses are two-dimensional stresses. Okay, X and Y direction. Okay, little bit. It's okay. It's kind of right answer. Any other answers? This is which kind of force?
Tensile force.
Tensile force. It's a one-dimensional.
Yes, sir.
It's one-dimensional. If I am applying force like this is which kind?
2D.
Two-dimensional, right? So if for your syllabi, you are having only 1D and 2D. So now I am not going to touch the other part. It's a three-dimensional one. Okay. Okay. So now, which kind of forces these are? These are which kind of forces? So these are normal forces, or these are shear forces, or these are any other kind of forces. So which type of forces? Whatever I am representing on the figure, which type of forces these are? These are normal axial forces, pure axial forces acting on the axis, right? So this is termed as sigma x. This is termed as sigma y, right? So two-dimensional stress system. So here there are different terms. That is principal stress, principal stress, principal stress, principal stress, or and also well before going to principal stress, we have to define principal plane, principal plane, principal plane. What is mean by principal plane? Principal plane. See, the stresses which acting on principal plane, those are called principal stresses. So what is mean by principal plane? That is very, very important. So keep in your mind the plane which is not having shear stresses. There is no shear stresses on principal planes. Those types of planes are called pure principal planes. See here for X acting, which is the plane? This one.
Yes, sir.
On the surface, any shear forces are acting?
No.
No. Shear force is 0. That's why for sigma x, this is the principal plane. This is the principal plane. For this sigma y, which is the plane? This one. Is there any shear force? No. Hence, for the sigma y, this is the principal plane. For this force, this one is the principal plane. For this force, this one is the principal plane. So the plane in which there is no shear stresses, that plane is called principal plane. And with respect to this plane, sigma x is the principal stress. With respect to this plane, sigma y is the principal stress. Similarly, this is sigma x, sigma y. So any doubts? Any doubts?
No,
Clear?
sir.
Okay. See, for an example, if shear forces acting on the surface, then where we can expect principal plane? That is very, very important concept. See, here I am just briefing in a little bit a simple manner. Don't make it as complicated. Don't read any textbooks. Don't go through any YouTube or any other videos. If you go to some other materials, you are getting confusion. So please be focused with respect to whatever the interaction for, especially for MCQ. Okay, so now see, this is pure, there is no shear force, this is pure axial forces. Okay, now let's say another 2D I will consider. Here in this stress system, sigma x is acting, sigma y is acting, similarly sigma x is acting, and sigma y is acting. And also with respect to this, I will consider shear. So these are the two equal and opposite shear forces. So because of these two forces, how it is rotating? How the body is rotating? In
Clockwise.
which direction?
Anti-clockwise.
Anti-clockwise direction. But strictly speaking, in mechanics of material, whatever the body we are considering, that must be in equilibrium. To bring the body in equilibrium, what we have to do? We have to apply one more pair of equal and opposite forces. Now just observe, the body is in equilibrium. It is not moving anywhere because these two pair will resist this anti-clockwise moment. Now the shear forces, say you can say this is for tau xy, this is also tau yx or tau xy. Both are same. Now this body is in equilibrium. Now see, for this case, if this plane is principal plane or not. Are you getting my question? For sigma x, which is the principal plane now? See, don't be confused. For this case, whatever I have written, this is a pure normal force acting phase. Whatever this. For this, the principal plane is correct. But for this, here, shear forces exist. On this plane, tau xy is acting. On this plane, tau xy is acting. On this plane, here also tau yx is acting. On this plane, tau ys is acting. Then where we can expect principal plane? See, the principal plane for these cases, they may act anywhere of the body like this, anywhere inside the body with inclination always with respect to vertical. So now this is the principal plane. If I'm considering that plane only, you just observe over here. This is the inclined plane, that is the principal plane. What happens? Here, perpendicular to the plane, whatever the force develops, that is called normal stresses, sigma n. And here also there is one more force with respect to parallel. That is not shear, that is tangential, sigma t. See, whatever I have written, I have just elaborated the thing like, just observe here. So now this is your figure diagram. I just expanded this thing. This is theta. Now this is the plane. It is not having shear stress. So for this kind of problem, you may expect principal plane inside the body. That principal plane will develop two kinds of stresses. For this principal stresses are sigma x, sigma y. But for this case, the principal stresses we have to compute. Direct normal stress we are getting, one tangential stress we are getting. And also with respect to this, we have to compute major principal stress axis and minor principal stress axis. Okay, so sigma n, we are having two various methods. One is by analytical computation. So sigma n can be computed using the equation. You have to remember this equation. Sigma n equals sigma x plus sigma y by 2, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into sine 2 theta plus tau xy cos 2 theta, tau xy cos 2 theta. Okay, so you have to remember this equation. Sigma n equals sigma fx. See, this is cos 2 theta, and this is sin 2 theta. If you are taking this is sine, this is cos, then it will become sigma t. That's the only difference. Okay, first you take cos term, next you take sine term. So this is the normal stress. Similarly, sigma t equals the same thing, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta, that is sin 2 theta here, sin 2 theta plus tau xy into cos 2 theta. So this is sigma tangential stress. This is sigma normal stress. See, these are the equations you have to just these kinds of problems we can easily solve using Mohr circle method, or we can use some trial and error method. Well, I will tell you how to solve by trial and error method while we are solving MCQ question. Why you have to remember this equation? The thing is, you may expect direct MCQ. By seeing the equation, you have to judge. Clear? So that is very, very important thing. So next, I will explain how to compute, that is major principal stress and minor principal stress. I have explained, the thing is, we are getting principal planes. So what I explained, the thing is, principal plane is for two-dimensional shear stress as well as axial stress system. We are having normal stress and tangential stress on the plane. But with respect to element, we are getting two stresses, that is major principal stress and minor principal stress. Okay, so the major principal stress is computed using sigma 1 equals sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 whole square plus tau xy square. For an example, in some cases, I will take one small example. See, here I will take, this is 20 kilonewton, here 20 kilonewton, here 30 kilonewton, here 30 kilonewton. Also, I will consider the shear stress on the plane, that is 20 kilonewton per meter square. Here also I will consider the same. Here also, whatever the 20, here also say 20. See, for this problem, what is the major principal stress? So in this problem, sigma x equal 20 kilonewton, sigma y, what is sigma y? 30 kilonewton. See, the sign convention is right side positive, upward positive. So general sign convention, downward negative, left side, that is negative. The thing is, these are tensile forces with respect to object. They are moving away, or tensile positive if acting towards the origin, that is negative. See, this is acting away. So we have to adopt to one sign convention, that is compression negative, tension positive. Okay, compression negative, tension positive. So this is tension. So this is positive. And this is also tension, it is positive. And tau xy, that is 20 kilonewton per meter square. Now you just substitute to this equation, you are getting sigma 1 value. That is major principal stress. That is major principal stress. Similarly, if you want minor principal stress, that is sigma 2. It's a direct equation, sigma x plus sigma y by 2. Instead of plus, you have to take minus. Remaining equations are same. Minus sigma y by 2 whole square plus tau xy square. Okay, so if you substitute all these values, you are getting sigma 2, that is minor principal stress. Minor principal stress. One is major principal stress and another one is minor principal stress. The two stresses are very, very important. And one more thing, shear stress. Shear stress. What is the shear stress? So shear stress, you have to remember one small equation, that is maximum shear stress. Maximum shear stress, that is tau max. Tau maximum equals, that is sigma 1, whatever here we are getting, minus sigma 2 divided by 2. So these three equations are very, very important equations. These three equations are very, very important equations because more or less several MCQ questions are related to these equations only. Very rare case, whatever previous equations I have given, these equations are very rare. They will ask more or less all problems on these three equations. So please be remember what is major principal stress, what is minor principal stress, and what is maximum shear stress. So major principal stress is the stress acting on a principal plane, that is the maximum value. Minor principal stress is the stress acting on a principal plane with the minimum value. It may be negative. Both the stresses are maybe negative or maybe positive, whatever it may be. Maximum, minimum. Maximum value, major. Minimum value, minor. And shear stress, that is tau max, maximum shear stress. So these three equations are very, very important when we are solving principal stresses problem. So in two-dimensional stress analysis, we are having one more important concept. So what is that important concept we will discuss? That is Mohr circles method. Have you having any idea regarding Mohr circle? Kedidira Mohr circle anta? Yes. So in third semester, you have what the thing is Mohr circle method. Okay. Okay. I'm seeing the time. If time permits, then only I will go for that particular thing because it takes some time to explain the Mohr circle. So I will explain in the presentation. Yes, this one. Yes, principal stresses, principal planes. So I have just briefed within whatever the 5-10 minutes regarding that particular thing. So principal stresses and principal plane. That is in whatever in previous section, but we discussed only the normal stress, shear stress, whatever acting independently. That is in one dimensional. But in a system, if it is acting simultaneously, shear as well as normal, that is your principal stress, that is two-dimensional stress system. Okay, so stresses on inclined plane. So this is the thing I have explained. Sigma x in two direction, that is x-axis, sigma y in y-axis, tau is a shear. See, don't be confused because whatever here in tau value, whatever here you are having, these two are equal, these two are always equal. You are not getting two different values. But you just see the thing, sigma x is different. These x values are same. These y values are same. These are pairs. These are two pairs. That is, this will cause tensile. And these two pair will cause tensile. And one pair will cause shear. So here there are three pairs. One is sigma x, another one is sigma y, and one more pair is shear, tau. So don't be confused. There are in this particular system two normal forces. What are two normal forces? Sigma x and sigma y, and one shear, that is tau xy equals to tau yx. So only three kinds of forces, two normal forces, one tangential forces. See, where these kind of figures or these kinds of numericals are expected, the principal plane within the element. The principal plane will be within the element. Here, this is not the plane. Here, the inclined plane is your principal plane. AC is the principal plane. And theta is the angle of inclination of plane. Theta is the angle of inclination of the plane. With respect to plane, I have already explained, you can expect two stresses. Two stresses, not shear. Two stresses. One is sigma n, another one is sigma t. I am not representing by tau t. It is not tau t because On the principal plane, there is no shear stresses. On the principal plane, there is no shear stresses. Okay. But if there is no shear stresses, then what is the case? We can expect the principal plane on the face of the element directly. On the face of the element directly. So this is the equation, that is sigma theta or sigma n, which is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta tau xy sin 2 theta, and also tau theta, tau, that is on plane with respect to tangential. These are the two things you have to remember, and also principal stresses and principal plane. What is mean by principal planes and principal stresses? Planes across the only normal stresses are there. There is no shear stresses, that is called principal plane. So now the normal stresses across the principal planes are called principal stresses. Principal stresses. See here, there are sigma x, sigma y. Whatever in previous case I have given, both are tensile nature. It is not mandatory to be tensile. It may be compressive. Okay. If it is compressive, you have to take negative sign convention. If it is tensile, you have to take positive sign convention. So with respect to two normal stress and one shear stress, you are expected to get one major principal stress and another minor principal stress. So sigma 1, sigma 2. Sigma 1 is sigma x plus sigma y by 2 plus. For major, you have to take positive. For minor, you have to take negative. Sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 whole square plus tau xy. See, please remember this equation. These equations are very, very important because you are having one more topic, that is failure theories. In failure theories also, Rankine's theory, Van Arn's theory, whatever it may be, you have these equations of principal stresses are repeatedly coming in MCQs. So that's why whatever I'm saying is, you remember these equations. Sigma 1 equals sigma, that's major principal stress, sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 whole square plus tau xy square. Here I have given in one for plus, sigma 1 you take plus, then sigma 2 you take minus. For sigma 1 you take plus, for sigma 2 you take minus. Okay. Then position. See where exactly the principal stresses will locate. Position of principal stresses with respect to vertical plane. I just explained you. Always principal stresses are acting with respect to vertical plane. You may expect directly in MCQ. Principal planes are always inclination with respect to x-axis, z-axis, y-axis. That is y-axis, vertical. Vertical is y-axis, or abscissa, ordinate, or some other like z coordinate. That is, that's always acting with respect to ordinate, not with respect to abscissa. So these are the general question you may expect in your MCQ questions. So this is regarding, you have to remember this equation also, tan 2 alpha equal to tau xy divided by sigma x minus sigma y. Okay. Next, maximum value of shear stresses. This is the equation you have to remember, or you can directly remember tau max equal sigma 1 minus sigma 2 by 2. So, or you can take the equation square root of, you're getting the same answer. If in a question they are not asking to compute major, minor, they will ask directly compute the shear stress value. On that case, you have to take this equation, that is square root of sigma x minus sigma y by whole square plus tau xy square. If you don't know, you just remember those two equations, that is sigma 1, sigma 2, compute sigma 1, compute sigma 2. Then take sigma 1 minus sigma 2 by 2. We are getting same answer. We're getting same answer. Okay. So next, that is plane maximum shear stress. It's the average. Sigma 1 plus sigma 2 by 2. That is maximum shear stress on normal stress. So next, Mohr circle. So we are having time to explain Mohr circle. So only 10 minutes is we are having time. So if I take Mohr circle, it will take 10 to 15 minutes to explain because it's a very, very important concept. So tomorrow we will explain Mohr circle. So we are having 10 more minutes. So we'll take MCQ on whatever we discussed now. Okay. Shall we move on to MCQ? Shall we move on to MCQ?
Okay, sir.
Yes. So any doubts? Yes, please tell me if you are having any doubts. I will explain now. Then later on we will move on to MCQ. No problem. Any doubts?
No, sir.
No. Okay. Shall we move on to MCQ?
Sure, sir.
Okay. Yes. I have stated some of very important problems. So generally you are getting 1 or 2 questions. Sometimes they may ask 2 questions. This is related to Mohr circle. Okay, I will take afterwards this one. Okay, we will take 1 or 2 problems now. Okay, this is the question. It's on Mohr circle. It's not related to Mohr circle. Okay. Okay. 17th question. If an element stressed by a body in a pure shear state with a magnitude of 80. So this is question. If you know Mohr circle, you can do easily. So that's why I'll take afterwards, because that is also related to Mohr circle. Okay. Take the 18th or 19th. Both are okay. Both are good problems. If we take the 18th one. So this is, we can use equation easily. Okay. At a point in elastic medium, normal stresses is 2 mutually perpendicular directions. So what is meant by 2 mutually perpendicular direction? This is the case. 2 mutually perpendicular, which means sigma x, sigma y are tensile. 2 mutually perpendicular directions. With first one, this is sigma x. How much? 120. And sigma y, how much? 40. This is also 120. This is also 40. Associated with the tangential stress. I have already told you, you are getting only 3 values. One is for sigma x, another one is for sigma y, and tangential for sigma xy. So if you take like this, here also if you take like this to maintain the equilibrium, so this is 30 and this is also 30. So now you got sigma x, sigma y. What is this asking? Principal stresses. So what are principal stresses? Sigma 1 and sigma 2. What is sigma 1 equation? What is sigma 1? Sigma 1 equals sigma x plus sigma y by 2, that is 120 plus 40 by 2 plus square root of sigma x minus sigma y by 2 whole square plus tau xy square. What is tau xy square? 30 square. Please compute the value sigma 1 and you put minus and compute sigma 2. That's all. Okay. What is the value of sigma 1? 120 plus 40, that is 160 by 2, 80. 80 plus how much you are getting? 120 minus 40 by 2, that is 60. 60 square. 80 square plus 30 square. Right? 120 minus 40, 80. 80 by 2, 40. 1600 plus 900, 2500. Square root of 2500, we're getting 50. Right? Square root of 2500. See, calculator beda, you direct yochana madbeku. So you are getting 130 MPa. For this 80 minus 50, right? You are getting 30. So what is the answer? Both are positive, right? Both are positive means both are tensile. What is the option? Yes. Option? Option? B. 130 MPa, 30 MPa, both tensile. Both tensile. So any doubts? Yes? Manohar, any doubts?
No, sir.
Okay, okay. Okay. So have you got the thing? Direct substitution. Direct substitution. You have to use the equation directly. You have to use the equation directly. Okay. You just see the next question. Next question also, what he is asking? He is asking normal stress. See, be careful. This is not principal stress. This is not principal stress. What is this? This is normal stress. What is the equation for normal stress? Sigma n equals sigma x plus sigma y by 2. sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau xy into sine 2 theta. Here theta is 45, sigma x is 50, sigma y is 10, both are tensile. See, he's given the reverse direction. See, in previous case I have taken positive y. Here the tensile directions are clockwise. Here the tensile directions, tangential directions are anti-clockwise. That's why he is given negative. So tau xy is minus 40 you have to take. So you just substitute, you are getting the answer. How much you are getting the answer? Sigma x value is 50 plus 10, 60 by 2. So you are getting 60 by 2. 60 by 2 is 30, right? 30 plus sigma x, 50 minus 10. 50 minus 10 is 40. 40 by 2 is 20 cos 90. What is the value of 20 cos 90? What is cos 90? Yes, calculator use ಮಾಡಬಹುದಪ್ಪ ಮಾಡ್ರಿ. Is 0. What is the answer? 0. Now tau xy sin 2 theta, sin 90. Tau xy is minus 40. Yes, how much? What is the answer? Okay, I don't bothering about calculations. You do the calculation. Just tell me the answer. What is the answer? What is sigma n? What is the value of sigma n? See, these are very, very important questions. Whatever I have picked the question, these are very standard questions. If you perfect for this question in your examination, you will easily tackle whatever the kind of questions they may ask. Okay? How much? 120. Yes, any other answers? Avinash, how much? What is the option? A, B, C, D. Which one is the correct? Yes, what is the option? How many of you got the answers?
So I'm
Who is
getting
SG?
minus 10.
Estapa?
Minus 10, sir.
Minus 10. Yes, any other answers?
Hello.
Yes, Rahul?
Yes, sir. We are getting minus 10, sir.
Minus 10. Okay. Others?
50 MPA ಇದೆಯಲ್ಲ ಸರ್ ಅದು ಮೋಸ್ಟ್ಲಿ ಮೈನಸ್ ತಗೋಬೇಕಾ
ಏನಮ್ಮ?
ಮೈನಸ್ 50 MPA ತಗೋಬೇಕಾ ಸರ್ ಅವಾಗ ಮೈನಸ್ 60 ಬರುತ್ತೆ ಸರ್
ಎಲ್ಲಿ?
ಕಂಪ್ರೆಸಿವ್ ಫೋರ್ಸ್ ಇದೆಯಲ್ಲ ಸರ್ ಅದು 50 MPA
ಹೌದು, ಕಂಪ್ರೆಸಿವ್ ಫೋರ್ಸ್ ಇದೆ. You have to take minus 50. If you see this, if you take 50, that's wrong. That's why I'm smiling, because you have to see the diagram. In diagram, which type of force?
Compressive force.
Yes, what you have to take for compressive? What is the sign convention? Minus. See, sometimes what they happens, they will give 50 in theory, whatever question, but they will give the diagram. You must see the stress block diagram. So the answer is A.
Answer is 60, sir.
Yes, minus 60, right?
Yes, sir.
Yes, sir.
Answer is A. See, very good. You must observe the given stress block diagram. Clear? If is not given the stress block diagram, then your answer is right. If the answer is not an option, you just leave the question, you are getting grace. You can raise the query. Okay? But if they given the diagram, no use. We must go with the diagram only. It's a very, very important thing. Clear? Any doubts?
No, sir.
Okay.
No, sir.
Okay. We will wind up the class now, because only 1 or 2 minutes left. Okay. So in this particular class, what we studied few of the temperature stresses cases, and also we studied elastic constants, and also we studied the basic concepts of principal stresses. Clear? Any doubts?
Sir, we wanted PDF notes, sir, for this.
Yes,
No,
I
no.
will send. See, the thing is, the only one concept is remaining. The concept is regarding Mohr circle. So after the finishing of Mohr circle, I will share the PDF of. Okay, today only I will share the PDF of whatever the content and as well as MCQ. Clear?
Clear, sir.
Okay, I will share. Today only I will share. Tomorrow we will do MC, that is more circle, no problem. Tomorrow don't miss the class. I will try to cover more circle as well as we moving on to the next very curious topic, that is SFT and BMD. Sure questions. If you know SFT and BMD, then only you can do influence line diagram. That is very, very important. In your syllabi, I just saw the syllabi. You are having all influence diagram, truss, beam, all the things. Okay, so don't miss the class. Clear? Okay, shall we wind the class?
Okay, sir.
Any doubts?
No.
Okay. Thank you. Thank you all.
Thank you, doctor.
Thank you, sir.
Thank you, sir.